Hi, I'm Tim, and today I'll share our recent work on hallucinating pose-compatible scenes. Human pose can reveal a lot about a scene. Consider this example pose of someone doing a push-up. We know that the pose is likely in certain environments, such as a gym or exercise room. The scene must also have suitable affordances, such as enough floor space. Our generative model implicitly infers these constraints. Given pose's input, we are able to hallucinate compatible scenes. We train a large-scale conditional GAN to accomplish this task. The objective is simple: generate scenes such that a human placed in the input pose results in a realistic image. Our model also learns object interactions, such as a person squishing down an exercise ball or riding a horse. It even learns occlusion reasoning. Legs are not visible in the bottom input pose, and our model hallucinates a kitchen countertop to occlude the legs accordingly. One way to think about what our model learns is through the lens of scene affordances. Affordances describe the possible uses of an object or environment. Prior work on affordances often infers likely poses provided an input scene. We consider the other side of the same coin and propose the opposite task: infer likely scenes given pose. We substantially scaled the complexity and size of data used for training, curating a dataset of 19 million frames of humans performing everyday activity. This is much larger and more complex than common GAN datasets, such as FFHQ, which contains 70,000 images of faces. We source the data from 10 existing action recognition and human video datasets, and heavily filter for high-quality images of scenes with humans. Our model is a pose-conditioned GAN, based on a scaled-up version of StyleGAN 2. We double the channel width of both the generator and discriminator, which we find significantly improves performance on our complex dataset. Pose conditioning is used in two ways: for placing humans in the right position, and for producing scene latent codes for compatible scenes. We can generate scenes without a human at test time by simply zeroing out the heat map conditioning used to place humans. We can sample different compatible scene latent codes by conditioning on the same pose, yet providing different input noise. In addition to improving quality and allowing us to generate scenes without humans, using these two pose conditioning mechanisms enables many applications. One particularly interesting application is to visualize incompatible scenes and poses. Here we force the scene latent codes and poses to be combined from different samples. The blue diagonal corresponds with scenes generated for the correct input pose, whereas all others show mismatched poses and scenes. Not all scenes and poses are compatible. This highlights an important difference between our data and other datasets commonly used when training GANs, such as faces. Any face could have any color hair, glasses or no glasses, and still produce a valid image. The assumption that all image attributes can be composed with all others is not true for our data, and motivates the importance of learning compatible poses and scenes. Additional applications of our pose scene disentanglement include placing generated people in new scenes without changing human appearance, animating pose within a generated scene, and leveraging scene clusters to shrink the sampling distribution at test time, which helps mitigate generated image artifacts. Our model suffers from some failure cases. Examples include generating partial objects such as a bike, poor overall image quality, missing limbs without occluders, and trouble placing objects such as a golf club in a person's hands. We report two numeric metrics against Pix2Pix and StyleGAN 2 baselines. PCKH measures accuracy of human placement, where higher is better, and FID measures image quality, where lower is better. Our model outperforms baselines in both respects, and we show full ablation experiments in the paper. Here are some more success cases demonstrating the diverse scenes our model hallucinates. Thank you, and please read our paper for more details.